Welcome students to another in our Investigating Science series. Today we're in grade 4 and we're investigating the properties of air. Now we will be guided by these questions. What is air? How do we know that air exists? And how can we prove that air has mass and occupies space? Now let's see what we remember about air. Now, of course, air is all around us, and you may not be able to see the air, but how do we know that it exists? We may be able to see its effect on different substances. Now, air represents matter, and so all matter has mass and occupies space. So everything that we see around us, solids, liquids and gases, represent matter. And so air is a form in which matter exists. So how are we going to be able to carry out our investigation? We're proving, or we're trying to prove, that air has mass and occupies space. And as you can see in the diagram, we will be using some everyday materials to prove this particular theory. All right, so what will we need for this investigation? As you can see on our table, we have a container with water, plastic cups, a piece of paper towel that we're going to crush, a clothes hanger, regular clothes hanger, some balloons, and some clothespins. And we're going to see how we can use these simple materials to show that air represents matter and it has mass and occupies space. Okay, so let's look at our method. What are the steps that we'll use to accomplish this? So first of all, we're looking at the first question, whether air has mass. All right, so I have with me here some balloons. We're going to take 2 balloons. We're taking balloons that are similar in size. All right, and we're going to try to blow up this balloon. Now when I blow up this balloon, I want you to think about what property of air is proven when I blow up this balloon. So I haven't done this in a while, so let's see. All right, and we want to ensure, so when I blow in this balloon, what does this show? What does this show? What is in this balloon? What has caused it to change its shape? All right, think about that, and we'll answer that in a bit. Now I'm going to tie the end of this balloon, and I'm going to try to attach it to this clothes hanger. Hopefully it stays. All right. All right. So if we should try to put this in the middle, you'll see that our balloon is slightly tilted to one side. All right. Okay, now what would happen if I blow up another balloon and attach it to the other side? Let's find out. And we want to blow up our balloon to ensure that it's roughly about the same size as the first one. So let's see if we can get that done. This thing is tough. I tell you, I need some more strength. No, a little bigger. Is that about the same size? About, or maybe not. Anyway, so we're going to put it at the other end of this hanger and try to And we want to ensure that it's around the same distance apart from the end, so does it look a bit more balanced now? All right, so we have attached this using the same type of balloon and approximately similar sizes. We're going to be looking to see that in this particular case our clothes hanger looks balanced, just as if you would be on a seesaw. All right, so now what would happen if I would prick one of these balloons with a pin? So look at carefully. We're going to prick it, that this end is now tilted. All right, and so we want to look at this particular observation and determine what actually happened here. What does this particular investigation prove? What was it that was responsible, right, for keeping this hanger balanced in the first place? What property of air was responsible for that? So we will answer that question in a bit. So I would want you just to think about that so that we can get answers to this particular question. All right, so let's continue with our investigation. We want to take this balloon out of the equation for a bit. And we're now looking at another investigation. So we have a trough with water. We're going to try to put some more water in it. Any container that's transparent, we have one of those glass containers, would be even better. All right, and so very simple experiment. We have pushed down into this plastic cup a piece of paper towel in this case, and we have crushed it and we have forced it all the way up to the top. Now, what do you think would happen if I place this cup in the water like this? What do you expect to happen? Make a prediction. Will this paper towel become wet, or will it remain dry? What do you say? All right, so let's try. So we have forced this all the way to the top. All right, and I hope the camera will get to see what's happening here. All right, so we're inverting this cup and placing it here, and if the camera can zoom in, you will see that the paper towel at the very top here remains dry. Okay, so the paper towel is dry, it is placed in a container with water, and we're trying to figure out how can that be, right? We have placed paper in water and it is still dry. What is the explanation for this? All right, so we're going to try to figure that out in a bit, but if I should bore a hole, all right, fell again, but if I should bore a hole in this container, it would actually allow the water that was not able to wet that towel to come through to wet it eventually. All right, so we want to find out an explanation as to why, when we inverted the cup in the first place, the paper remained dry. So let us look back and see what our observations were. What were our observations? So in the first place, with the balloon, we noticed that the size of the balloon changed, right? When we blew in that balloon, right? And we were blowing air into the balloon, right? And of course, when we burst one of the balloons, we saw that the hanger became unbalanced, right? So those were our observations. With respect to the paper and the cup, when we placed the paper in the bottom of this container and pushed it all the way down into the water, we realized that the paper remained dry. Okay, so let's see how we can figure out what is happening. Let's look at some questions. What property of air caused the balloon to change size? What was the property of air? When we blew into the balloon, right? The air, which is a mixture of gases, caused the balloon to change in size. And what that is showing was that air, as a type of gas, has this ability to occupy space. So whatever space we place air or any form of gas in, it will occupy that space. Now, when we place the hanger on this clamping stand and added our balloons, right? In the first place, when we had both balloons on, they were about balanced, right? But when we burst one of the balloons, it became unbalanced. Now, in the same way, if you had a heavy person and a light person on a seesaw, right? And once that person gets up, the seesaw will change position because of the mass of the person. And so this particular experiment would have proven that air has mass. So although we cannot see it, sometimes we can feel the effects of it. We may not be able to touch it, but air has mass and occupies space. All right, the second experiment, we're looking at what happened with the crushed piece of paper. We pointed out that it was in this, it remained in the top of this container, this plastic, but it remained dry. Why? Because when we pushed down this cup into the water, there was some column of air that was in this cup, right? And so the column of air prevented the water from reaching that piece of paper, and hence it remained dry. So this proved to us, of course, that air, again, occupies space. Good, very good. I hope you enjoyed that. So what are our conclusions based on this investigation? We have shown, right, that definitely air occupies space, seen in the size of the balloon changing when we blew in it, and of course also seen in the fact that the cup that had the piece of paper, when we inverted it, that paper remained dry because air was already in the cup occupying a particular space. All right, and by balancing our balloons on our hanger, right, and when we burst it, we realized that our hanger became unbalanced because air definitely has mass. And so these investigations prove to us that air, being a type of matter, has mass and occupies space. And since air is a mixture of gases, all gases will therefore show these properties. That's all for today, students. We hope to see you next time on Investigating Science.